Hi and welcome to Quick Add Maths on inverse functions. The inverse of fx is written as f minus 1 in superscript form x. As an example, when fx is equal to 10x minus 3, you start by letting y equals 10x minus 3, then write x in the form of y. The inverse of fx is simply attained by replacing the variable y with the variable x, and in this case is equal to x plus 3 divided by 10. There are three things that are worth noting with respect to the inverse of the function x. Firstly, the graphs of fx and the inverse of fx are reflections of one another against the line of y equals x. Secondly, inverse functions exist only in one-to-one functions. Thirdly, self-inverse functions apply for functions with symmetry about the line y equals x. One example is for fx equals 1 over x, where the inverse function is also equal to 1 over x. Now on to tutorial question 1. Find the inverse function of fx equals, in brackets 2x minus 3, all square plus 1 for a domain where x is larger than 1.5. As in the earlier example, you start by letting y equals to the expression for fx. You would then move on to identify x in terms of y through some rejuggling. The solution of inverse fx is purely obtained by replacing the variable of x onto the variable of y. Tutorial question 2. Solve for the inverse gx equals 5 when gx is equal to 2x plus 3 over x minus 1 for x larger than 1. Once again, you let y equal to the expression for gx and find x in the form of y. Having identified the inverse of gx, one now needs to equate the expression for gx being equal to 5 and solve for x. Tutorial question 3. Where fx is equal to 2 to the power of x, draw the lines for y equals fx and y equal to the inverse of fx. As shown on the right, in drawing y equals fx, one can opt to plot some coordinates up front and join all these dots as shown on the green line. Next, the inverse of fx is purely a mirror image of y equals fx against the reflection line of y equals x, and this is what is shown in yellow. Y equals the inverse fx. Tutorial question 4. Draw fx equals to 2x plus 2. Use the reflection line y equals to x to determine the inverse of fx, and confirm its correctness by solving the inverse of fx mathematically. The first part of the question requires us to identify the inverse of fx using a graph. By looking at the graph on the right hand side, fx is determined by applying the concepts known for y equals mx plus c, where m is 2 and c also being 2. This would create the line in green on the graph. Next, we reflect against the line of y equals x to obtain the inverse function of x. This is the yellow line. As the line has a gradient of half and it intersects the y-axis at -1, the inverse function of x is therefore equal to half x minus 1. The second part of the question requires us to confirm by solving the inverse of fx mathematically. Therefore, we'll do the usual of first letting y equals the expression of fx, then identify x in the form of y. This should come to also half x minus 1. Now on to tutorial question 5. Check the table as appropriate. For the question, only for the functions of fx equals x and fx equals 1 over x, you would see that the value of fx is equal to its inverse function. For all the rest in the question, it is not. That's all for inverse functions. If you found this beneficial, do look out for our other tutorials.